All right, so hi everyone. Welcome to our presentations of findings for the photocatalytic roofing granules by 3M. We're going to discuss a product today by 3M that removes smog from the air, which is a dangerous byproduct of the combustion process. As you can see in this photo here, that's smoky, foggy haze in Toronto. That is smog. So we're going to play a little video for you in northern China. They experience very bad smog in their everyday life. So here's a little glimpse of that. So as you can see, visibility is very poor. Many people are wearing masks to protect themselves. So our product here will help mediate this problem by converting that gaseous smog you see into a very non-dangerous product. And so it's a passive solution that doesn't require energy. It uses the sun's energy. It will increase visibility in cities and increase the air quality in those cities as well. And so this is an overview of how our product works. So here's a little video 3M put out, and it's a good animation of how smog interacts with our product. So as you can see in this photo on the left, this is a cross section of one of the granules, one of the many granules that would be on top of the shingles. So you can see on the inside, there will be some kind of catalytic material. That would be the dotty space looking part of the photo. And then you can see there's a photocatalytic coating around it, which enhances the reaction of the catalyst. So here's an overview of our slide that we drew. So so first Skylar will be explaining the catalyst, and then Vitaly will be explaining the photocatalytic coating around the catalyst. Then Bahir will go on to talk about the oxidation reaction that occurs on top of the shingles. And then finally, I will be talking about how the products of the reaction dissolve into water and wash away. So Bahir, take it away.
Okay, so have you guys ever wondered what you think one of the most important things is on Earth right now? Like what would you say one of the most important things is? Well, for me, I'd say one of it is energy. Because without energy, we can't do a lot of things. Most of the modern day inventions would be pretty much useless. So now why are we interested in energy? Well, my subtopic oxidation reaction is basically a reaction that has to do with the release of energy. So anytime an oxidation reaction occurs, energy is released. Now, why is this important? Well, if energy is really important and we can understand the concept behind energy, then we can basically control energy, and that can help us in so many different ways. And I feel like that's a very, very amazing fact and a very interesting topic to look into. So now, by being able to understand the concept of oxidation reactions, we can understand this very important process. Now, what exactly is an oxidation reaction? An oxidation reaction is a reaction that involves the transfer of electrons between the two reactants. Now, for an oxidation reaction to occur, a reduction reaction must also occur. What's a reduction reaction? It's just the opposite of an oxidation reaction. So for an oxidation reaction, an electron is gained by the reactant to become oxidized. So for a reduction, electron is lost for it to become reduced. Example of some basic oxidation reactions like combustion, browning of fruits, fire, photosynthesis. As you can see, there's so many useful uses of oxidation reactions. Now on to my next slide. How nitrogen dioxide is converted to nitric acid. This is the main point that I have tried to look into and the solution to my research question. So nitrogen dioxide is turned into nitric acid through the oxidation process, but how exactly? First, an oxidation reaction occurs between nitrogen dioxide in the air, that's the chemical name for smog, and oxygen, which is naturally found in the atmosphere as well. This produces a water-soluble ion, which is called dinitrogen pentaoxide. It sounds like a very complicated name, but it's just an oxidized version of smog, which is more soluble and easier to dissolve in water. So because of this, the nitrogen pentoxide actually does dissolve in water and becomes nitric acid. So this is the process of how nitrogen dioxide is converted to nitric acid. And I would now pass it on to the next presenter, Kevin, who will speak about his own subtopic. Thank you.
Hi everyone. So today I'm going to talk about the coolest molecule on the face of the earth, and that is water. Water makes you live every day. You need it to live, you need it to function. It is one of the most powerful and amazing molecules you can look at. So in order to talk about how the products of the reaction but here discussed wash away, first you need to understand those molecular forces associated with water. So we're going to talk about polarity and solubility. So as you can see with this photo right here, this is a water molecule. And so the electrons have the oxygen molecule has a stronger pull on the electrons. So this end tends to be negative, whereas the other end tends to be positive. This is a very strong force making this molecule act as though like a magnet would, with one positive end, one negative end, and it gives the molecule the ability to rip pieces off. As you can see in this is a salt, and so it'll go in and it will pull off pieces and suspend them in the liquid, in the water, and it'll fully encompass them, removing the charge. So as you can see, I put on an example of salt dissolving. So you can experience that every day if you're making coffee, you're stirring your sugar into your coffee, it's dissolving, the water molecules are ripping apart the sugar and encompassing them and making the entire coffee sweet, as opposed to just one small sweet spot. So this applies to nitric acid as well, because nitric acid is it's a compound that doesn't have a charge. So these water molecules go in and they break this stable molecule apart into one positive and one negative charge, and then fully encompasses it and dissolves it into the water. This process will reduce the effects of the acid if there's small concentrations, and it's very, very useful in this sense. So we'll go on to the next slide, and you can see here's another diagram of the water molecules encompassing the positive and negative pieces of the acid. So after it breaks it apart, it encompasses it and kind of reduces the effects of it and dilutes it, and then therefore it puts it in a way where it can wash off and wick off the shingles and not cause any harm to the shingles. It won't contaminate the drinking water. It won't, if you put your hand in the water as it runs off the roof, it won't hurt you at all. So it's a very modest way of taking a very dangerous gaseous product, that's smog, and transferring it into something that is very harmless. And it's a very great environmental process to help clean up the air and make the world a little bit nicer to be in. So that's everything. So here we'll go on to some references that we have. And then thank you very much for listening. We hope you learned something today.